Find the area of the largest rectangle that can be inscribed in a right triangle with legs of length 3 and 8 centimeters if two sides of the rectangle lies along the legs. So here's the situation. We have a right triangle, one length 3 and one 8. So say 3 this one and 3 8. Let me draw it like that. So 3 is a vertical one and 8 is the horizontal one. Right triangle, 3 and 8. Now we have a rectangle inside that, inscribed in the right triangle. Two sides of the rectangle lies along the legs. So we could have something like that. So here's a rectangle. So the two sides of the rectangle is on the sides of the right triangle. So you imagine this point might be here. So in that case, we have this figure, or maybe here. And now we need to maximize the area of the rectangle. So they want the area of the largest rectangle. So we need to maximize this area. Let me call x is a length, say this length, and y this length. So we can compute the area of the rectangle, and therefore the remainder here will be 8 minus x. So this is what remains, 8 minus x. Yeah, we can relate x and y. Let's do that. Area of this rectangle is x times y. So that's the first thing. We need to maximize that. We need to maximize that. X and y as length. So for now we know that they must be bigger than 0. And you see that this x and y is on this length, so y is less than 3. X on this length, so x less than 8. 0 less than x less than 8. 0 less than y less than 3. So we know these two conditions. Look at this right triangle. It is similar to the bigger right triangle. So the right triangle I'm talking about is the yellow one and the original right triangle. They are similar. So this is 90 degrees. You have this length is y. So we have this condition. Y divided by 3, which is a short length here, divided by the long one, equal to this length divided by the total length. Y over 3 equal to 8 minus x over 8. I hope you understand that. We have two right triangles, the yellow one and the bigger one. They are similar. So this length over this length equal to this length over this length. Now we can rewrite x in terms of y or y in terms of x. In this case, y equal to 3 over 8, 8 minus x. So now we get rid of one variable. The area will now becomes x times y times 3 over 8, 8 minus x. So we have 3 over 8 8 times x minus x squared. This is area function in x, variable x between 0 and 8. So now we have the function, we have the domain, we can compute the maximum. I want to maximize the area of this one. You compute critical point, compute the derivative. A prime of x, 3 over 8, 8 minus 2x. This one is 3 over 8. I can pull 2 out, 4 minus x. So 3 over 4, 4 minus x. This one is 0 if and only if x equal to 4. We have one critical point. Now we have the table. X between 0 and 8. 4 is a critical point. A prime of x equal to 0 here. A of x, a prime of x equal to this. So on the left is opposite. So left on the right is agree with the side here. So agree. X less than 4, 4 minus x positive. X bigger than 4, 4 minus x negative. So therefore we have the size of a prime. Now a increasing and decreasing like this. Maximums right here. A of x is max if x equal to 4. So area, max areas are ax, x between 0 and 8 is a of 4. The formula for the area is this one. Or maybe I use this formula. This one I use this for a of x to compute that here. So 4 times 3 over 8, 8 minus 4. So this is 3 over 2 times 4. So 3 times 2, the area equal to 6. So our answer is maximum area equal to 6. That is the area of the largest rectangle. So this is our final answer.